Welcome to video series number 4, Volume Calibration with Imaging Modalities. In this video, we will review calibration of the volume signal using an end-diastolic and end-systolic volume derived from imaging. This method is best suited for applications where one seeks to monitor relative hemodynamic changes from an arbitrary baseline, as the accuracy of the volume calibration is limited by the quality of the imaging modality. That said, the relative or percent change from this arbitrary baseline is extremely accurate due to the high-fidelity nature of the PV loop catheter. Volume calibration can be performed during a case in real time or offline during data analysis. In both scenarios, one needs to have a minimum of one baseline file for which we can apply the volume calibration values. For our purpose, we will assume that we've already collected PV loop data and are choosing to calibrate the volume signal offline post-intervention. Start by opening the study for which we will be calibrating the volume signal. If you're in live data mode, this won't be necessary since we're already within that study. Next, rather than showing live data, we will be playing recorded data. From here, select the baseline file that is best for which we will calibrate the volume signal. All other corresponding files will be updated once we calibrate this file. By best, we are looking for the baseline file that has the least number of PVCs and has the most consistent pressure volume loops. It's not uncommon to have perfectly consistent and concentric PV loops, but this will depend on a stable catheter position and the nature of the patient. Notice upon first opening the PV loop file, a signal filter is no longer included. The first step will be to include this filter by going to Analysis, Filters, and selecting the appropriate signal filter. The default selections for selecting the end-diastolic and systolic points for the PV loop are appropriate for the time being. Select Apply, and then OK. You'll notice the blue dots, end-systolic points, and green dots, end-diastolic points, are updated based on this selection. Next, we'll quickly go through the file and remove any erroneous beats by excluding these specific beats and also updating the end-diastolic point in green as needed. Recall that the end-diastolic point is defined as the ECG R-top max from the ECG signal provided by the PV loop catheter. In this instance, the end of beat 1 is slightly off the R-top max, so I can adjust this by moving the green line in the appropriate location. By right-clicking on a beat, I can exclude a specific selection. I will move forward with time and look for any bad beats. Notice beat 9 includes several beats, so I'm going to exclude this entire selection. Same thing with beat 12. As I move forward, all other beats look good. From here, I will now go to volume calibration, which will immediately prompt me to save my changes. The first time I open the volume calibration window, we are in dataset 0. Recall that by default, our PV loop files are stored in dataset 1. Here are our data files. Next, I will highlight and select the baseline file that we have just cleaned up and apply the imaging values as follows. After inputting these values, go ahead and select Apply. From here, we'll need to reopen our study to look at the calibrated values. If you are calibrating the volume signal during a live case, go back to Show Live Data. But for us, since we're offline doing data analysis, we'll go to Recorded Data. Reopen the baseline file that was just calibrated. You will notice the volume signal is off the screen because it has been scaled appropriately based on the imaging values used. Rescale using F9 or the Rescale button. Upon clicking the Rescale button, you'll notice we can now visualize the volume signal, which is turned from red to yellow, indicating that it is calibrated. Similarly, the PV loop is turned yellow, indicating a fully calibrated pressure volume loop, and our hemodynamic matrix has been updated accordingly. We are now ready to analyze the data. Remember, we only need to apply the imaging values to one data file, and all other data files will be updated automatically.